Next problem. In a jar there is some mixture which contains milk and water in the ratio 5:3. If 16 liters of mixture is taken out and replaced with water, okay, 16 liters of mixture is taken out and replaced with water, okay, the ratio becomes 1:1. So find the initial quantity of mixture in the jar. It is same like the previous problem, okay. So initially milk and water, milk and water was how much? In the ratio 5:3. Then 16 liters of mixture is taken out, okay, 16 liters is removed. How much is removed? Taken off means removed. How much is removed? 16 liters, okay, and replaced with water. When 16 liters is taken out, what will be the remaining mixture? So whatever is the remaining mixture, that also will contain milk and water in the ratio 5:3, okay, and this was replaced with water, okay, again water was added, water is added, okay. So how much water is added? It was replaced. Always replaced means how much is taken out, that much only will be added, okay. So 16 liters of mixture is taken out and replaced with water, means that much only is replaced. That means 16 liters water is added. Then the ratio becomes, now the ratio becomes how much? Milk is to water, it becomes 1:1, okay. Now find the initial quantity of mixture. So what was the initial mixture quantity? Okay, initial mixture quantity was how much? Okay, this is the question. Now it is same like the previous problem, but see here, when 16 liters of mixture was removed, the remaining mixture also contains milk and water in the same ratio, that is 5:3. Then water is added, 16 liter water is added, then the ratio becomes 1:1, but only water is added, so milk has to remain same, but milk ratio is changing here, isn't it? Milk ratio is changing, so we have to make milk as same, okay. To make milk same, what we have to do? We have to multiply here with 5, then milk will become same. So how much will be the ratio now? 5:1 is 5 and 5:1 is 5. Now milk is same, isn't it? Here also it is 5, here also it is 5, but water is changing. See here, water is changing. How much it is changing? From 3 parts it became 5 parts, okay. That means water is increased. By how much? By 2 parts, isn't it? Water increased by 2 parts. So this increment in water is due to what? It is due to the addition of the 16 liter. So therefore I can say 2-part increment is due to the addition of 16 liters of water, okay. So then if 2 parts is 16 liter, then 1 part will be how much? 2 ones are 2 8s are, so it will be 8 liter, okay. So similarly we will find what was the remaining mixture first, okay. So remaining quantity was how much? Remaining mixture was how much? It was 5 parts water plus 3 parts 5 part milk and 3 part water, so totally 8 parts. So if 1 part is 8 liter, 8 part will be how much? 8 into 8, which is equal to 16 liters, okay. So this remaining mixture was 16 liters. So when was this remaining 16 liters? When 16 liter was removed from that. So then initially will be how much? Initially mixture will be how much? Initial mixture is 16 liter plus 16 liter, which is equal to 30. Initial quantity was 64, okay. This is 64. 8 into 8, 64 liters, okay. Okay, so now, so 8 into 8, it is 64 liters, okay. So the remaining is 64 liters. So when we got this remaining 64 liters, when 16 liters was removed from original, 64 was remaining. So originally how much it was? 16 plus 64 liter, which is equal to 80 liters. So initially the mixture was of 80 liters. Okay. Only change between the previous problem and this problem is, here milk ratio is changed. Okay, their milk ratio was same. It was same, no? So now milk ratio is changed. So to make it same, what we have to do? We have to multiply it with 5. Means whatever is the milk ratio, no, that only we have to multiply to make it same. Okay. Then when the milk ratio becomes same, then we can proceed with the problem. Okay. So next problem. A vessel contains 80 liters of pure milk. From it, 16 liters of milk is replaced by water. If the same process is repeated once more, then find the remaining quantity of milk in the vessel. Okay. So this we will solve using 3 methods. Okay, first we will solve it using basic method, then we will solve using shortcut methods, and then formula method. So such type of problem where you will have same process is repeated, such problems will have one formula. Okay, so this problem will solve it in 3 methods. Okay, one formula method, one shortcut method, okay, and one basic method. So first we will see basic method. So initially milk was how much? Initial vessel contains 80 liters pure milk. So initial milk was how much? 80 liters. Then 16 liters of milk is replaced by water, means 16 liters of milk is removed. Okay, it is removed. Then remaining will be how much? Remaining will be, if 16 liters is removed from 80 liters, remaining milk will be how much? 64 liters. Okay. Then what is added? Water is added, isn't it? How much? Same. It is 16 liters replaced, means 16 liters water is added. Now the mixture, now it will be mixture, it will not be pure milk. Now it will become mixture of milk and water. Now milk will be how much? 64 liter, and water will be how much? 16 liter. Okay, because 16 liter milk is removed, the remaining will be how much? 64 liter, and in that 64 liter, 16 liter water is added. So milk quantity will be 64 liter and water quantity will be 16 liter. So that means milk and water will be in the ratio 4:1. 16 ones are 16 fours are. Okay. So this is our first step, means first process. So they are saying if the same process is repeated once more. Okay, now the same process is repeated once more. So now again 16 liter mixture is now 16 liter is removed. Okay, 16, now again process will start from here. Okay, now again 16 liter is removed, but this time it is mixture, not only milk. This time it is mixture is removed. Okay, then after removing, what will be the milk and water? It will again, milk and water will be in the same ratio, that is 4:1. Okay, now we know that one part is water. Okay, if one part 5, okay, 5 parts is mixture, 5 parts is mixture. Okay, so this 5 parts is removed. Okay, 5 parts is removed, that means what? 4:1 was mixture, milk and water, then it was removed. When that removed mixture also contains milk and water in the same ratio, this is removed mixture. Okay, so the removed mixture also contains 4:1. So that means 5 parts is removed. 5 parts is removed and 16 liters is removed. So therefore I can say that 5 parts is equal to 16 liter. If 5 part is equal to 16 liter, then 1 part will be how much? 16 by 5, which is equal to 3.2 liter. So 1 part will be 3.2 liter, isn't it? Now how much will remain finally? Finally how much it remains? We know that milk and water was, now 1 part is 3.2 liter. So milk will be how many liters? Milk is 4 parts. Therefore milk will be how much? 4 parts. So 4 parts means how much? 4 into 3.2, which is equal to 12.8 liter milk. And water will be how much? 1 part. 1 part is nothing but 3.2. So water will be 3.2 liter. So in the remaining, after this first process, in the remaining mixture, 12.8 liter is, how much is there in a 16 liter? In a 16 liter, okay, in a 16 liter, milk is 12.8 liter and water is 3.2 liter, okay. So how much was remaining after first process? 64 was remaining, isn't it? And after second process, 12.8 is removed, milk is removed, and water from 16 liters it is removed. How much? 3.2. So 64 minus 12.8 is 51.2, and water will be how much? 16 minus 3.2 is 12.8. So this will be the remaining quantity of milk and water. Okay, so what is asked? Find the remaining quantity of milk in the vessel. So therefore milk, remaining milk is how much? Milk remaining is how much in the vessel now? It is 51.2 liters. Okay, so this was the basic method. So let us see now shortcut approach. So we will discuss both shortcut approach and formula method. Okay, now we know that always remember removed quantity divided by total. So this is the always thing we have to remember. So how much is removed? 16 liters is removed and total was how much? 80 liters. Okay, so therefore 16 divided by 80, so it is 1 za 5 za, so it is 1 by 5. That means one part is removed. Okay, one part is removed from 5 parts. Okay, from 5 part, 1 part is removed. Okay, so when 1 part is removed from 5 part, then remain, how much will remain? How much will remain? 4 by 5. When 1 is removed from 5, how much will remain? 4 will remain, isn't it? 4 part by 5 part will remain, isn't it? So this is first time. Okay, then second time, so from 80 liters, okay, how much will remain? 4 by 5. So this will be our first step. Then again 1/5 is removed. Again this process is repeated once more, isn't it? Again 1/5 is removed. Again when 1/5 is removed, again 4 by 5 will remain. Okay, so 4 by 5 of this part will remain. So again 4 by 5 multiplying. So this will be second step. Okay, how much will remain? 4 by 5 of this part will remain. Okay, so therefore total how much will be there? Which is equal to, multiply this whole thing. So it is 5 1s are 5 16s are. So it is 16 into 4 into 4, which is equal to 256 divided by 5, which is nothing but 51.2 liter. Okay, this is 51.2 liter remains. This same thing what we got here, isn't it? This was shortcut method. So now there is one formula for such problems. Okay, so what is that formula? remaining quantity, okay, remaining quantity is always equal to initial quantity, okay, initial quantity into 1 minus removed quantity divided by total, the whole raised to n. Okay, we'll write it once more here. Remaining quantity is equal to initial quantity into 1 minus removed quantity divided by total, the whole raised to n, where n is the number of times repeated, okay. So let us substitute the values. So the remaining quantity is equal to, initial quantity was how much, 80 liters, into 1 minus removed was how much, 16 liters from 80 liters in total. So how many times the process is repeated? It is repeated 2 times. So therefore 80 into 16 ones are 16 5s are, so it is 1 minus 1 by 5 the whole square, which is equal to 80 into 1 minus 1 by 5 is nothing but 4 by 5 the whole square, which is equal to 80 into 4 by 5 into 4 by 5. This is the same thing what we got here, isn't it? This, in after substituting in the formula, what we get, the same thing what we got this using the shortcut method, isn't it? So again, if you solve this, you will get same 51.2 liters. Okay, so these were the 3 methods how you could solve these type of problems. So we'll see the next one. 2 alloys A and B contain iron and silver in ratio 7:5 and 5:3. Okay, if equal quantity of both alloys are melted and recast into a new alloy, what is the ratio between iron and silver in new alloy? Okay, there are 2 alloys, that is A and B, and this contain iron and silver. Okay, both these alloys contain iron and silver in the ratio 7:5. A will have a 7:5 ratio and B will have 5:3. Then if equal quantity of both the alloys, okay, both alloys of equal quantity, equal means what, 1:1. Okay, if they are all equal quantities are melted, then how much will be iron and silver in this new alloy? Okay, now let me consider iron and solve the problem. You can either take silver or iron, any one thing you can take to solve the problem. So let us consider iron. Okay, now A and B. In A, how much is iron? It is 7 out of total how much, 12 part. So 7 out of 12. And in B, how much is iron? 5 out of how much, 8 parts. So it is 5 out of 8. So this has to be melted to form the third iron, that is X. Let that be X, we don't know how much it is. So this has to be melted in the ratio 1:1, isn't it? So from the alligation method, it is 5/8 minus X and X minus 7/12. So therefore we can say that 5/8 minus X divided by X minus 7/12 is equal to 1/1, isn't it? 1 is equal to this, this is equal to this. So when we solve this, how much it will be? Cross multiplying, 5/8 minus X is equal to X minus 7/12. X terms one side, so it is 5/8 plus 7/12, which is equal to X plus X. So we'll solve it here. Therefore it is 2X is equal to 29/4, 24. If you solve this, okay, you will get 29/24. Therefore, x is how much? 29 by 24 into 1 by 2, which is equal to 29 by 28 or 48. Okay, so x we got it as 29 by 48. But this was regarding iron, isn't it? That means if this was iron, then this was the total alloy. Okay, that means they are asking us what is the ratio between iron and silver in new alloy. So this is total and this is only iron from that. Okay, because we are taking everywhere iron by total, isn't it? This was iron by total, this also iron by total. So whatever answer we got here, this is also iron by total. Okay, but we want iron is to silver. So if in from total is 48, iron is how much in that? 29 parts. So silver will be how much? It will be 48 minus 29, which is equal to 19. So therefore the new alloy will have iron is to silver in the ratio 29 is to 19. Okay, 29 is to 19. So option A is the answer. So next problem. Ratio between milk and water in a 60 liters mixture is 3:2. When 20 liters of milk is replaced with 20 liters of another mixture having milk and water in ratio 4:1. So what will be the ratio of milk and water in new mixture? Okay, ratio between milk and water in 60 liters of mixture is 3:2. There is one 60 liters of mixture and it contains milk and water in the ratio 3:2. Then when 20 liters of mixture is replaced with 20 liters of another mixture, okay, that means 20 liters is removed from this. It is replaced means what? When it will get replaced? Always when something you remove, then only when something you add, it will get replaced. So removed is how much? 20 liters. So when 20 liters is removed, so remaining will be how much? Remaining will be 40 liters. Out of 60, 20 is removed, so 40 is remaining. So what the remaining also will have milk and water in the ratio 3:2. Then it is replaced with what? Another mixture, isn't it? Added another mixture of 20 liters. So that when you add that 20 liter, okay, that they are saying when it is replaced with 20 liters of another mixture having milk and water in the ratio 4:1. So whatever this 20 liter of mixture is added, this will contain milk and water in the ratio 4:1, they are saying. Okay, so that means new mixture will have, okay, whatever is the new mixture, that will have 40 liters of this mixture and 20 liters of this mixture, isn't it? 40 liters of this and 20 liters of this. So the new mixture will have this in the ratio 2:1. So this is new mixture. Okay, now we will consider milk and solve. Any one thing you can consider, so we'll consider milk. Now in this 40 liters, milk was how much? 3 parts out of 5. And in this 20 liters, okay, this 40 liters, in this 40 liters milk was 3 parts out of 5. And in this 20 liters, how much was milk? Milk was 4 parts out of 5. When these two are added, a new mixture will form and that will contain milk and water in the ratio how much? It will contain, it will have 2 parts of this and 1 part of this. So it will have 2 parts of this and 1 part of, 2 parts of 20 liter mixture and 1 part of 20 liter mixture. So now according to alligation, we know it is 4 by 5 minus x is to x minus 3 by 5. So I can equate it. So It is 4 by 5 minus x divided by x minus 3 by 5 is equal to 2 by 1. So cross multiply, will get 4 by 5 minus x is equal to 2x minus 2 3s are 6 by 5. So when you solve this, how much will get? X terms one side. So it is 4 by 5 minus plus 6 by 5, which is equal to 2x plus x will be 3x. So it is 10 by 5 is equal to 3x. 5 ones are 5 twos are, therefore x will be how much? 2 by 3. So x is nothing but 2 by 3. Okay, x we got it as 2 by 3, means we are taking milk and we considered milk and did it, isn't it? So if milk is 2 parts out of total, because always this is milk and this is total, so x also will be milk upon total. So if milk is 2 parts, then total is 3 parts. So water will be how much? Milk is 2 parts, okay, and total is 3 parts. So water will be how much? 3 minus 2, which is equal to 1 part. Therefore the new mixture will have milk is to water in the ratio 2 is to 1. Okay, milk and water in the ratio 2 is to 1. Next problem. A vessel contains 64 liters of pure milk and 8 liters of milk is replaced by equal quantity of water. Now 16 liters of mixture is replaced by equal quantity of water. Find the ratio between milk and water at the end of process. Now a vessel contains 64 liters of pure milk. Okay, it contains pure milk. How much? 64 liters. 8 liters of milk is replaced by equal quantity of water. Okay, that means 8 liters of milk is removed. Then what will be remaining? How much will be remaining from 64 if we remove 8 liter? 56 liter milk will remain. Okay, this is remaining milk. Then it is replaced. Replaced means always how much you have removed, that much is added. So 8 liters of water is added now. Okay, then now whatever we get, now it will be the mixture, it will not be pure milk because water is added. Now milk and water will be in the ratio of how much? Milk 56 was remaining, now water 8 liters is added. So it is 8 ones are 8 sevens are 7 is to 1. Okay, then now 16 liters of mixture is replaced by equal quantity of water. Now again what they are doing? 16 liters of mixture is removed. 16 liter is removed. Mixture is removed. So whatever is the remaining mixture, okay, 16 liters of mixture is removed. So mixture was how much now? 64 liters, isn't it? Because 56 plus 8 is how much? 64, means 8 liter was removed, 8 liter was added, means the initial quantity was as usual. Okay, that is 64 liters. So from 64 liters 16 liter is removed. So how much will remain? 64 minus 16, which is equal to 48 will remain, isn't it? So this 48 liter, whatever is remaining, 48 liter, okay, this will contain milk and water in the ratio 7 is to 1. Okay, from this, okay, so if they contain in the ratio 7 is to 1, so exactly how much liter they will contain? If total is 8 parts, okay, total is 8 parts and milk is 7 parts from 8, okay, 7 by 8 of 48 will be milk. So 8 ones are 8, 6 are 7, 6 are 42 liters will be milk. So if milk is 42 liters, then 6 liters will be 42 liters is milk, then 6 liters will be water, isn't it? So find the ratio between milk and water at the end of the process, they are saying. So at the end, okay, at the end, milk is to water is how much? Milk is 42 liter and water is 6 liter. So 6 ones are 6. So 16 liter is removed. So after removing 16 liters, 48 liters is remaining. In 48 liters, milk is 42 liter. We got this here, and water is 6 liter. But they are saying now 16 liters of milk is replaced by equal quantity of water. So when 16 liter is removed, again 16 liter water is added, isn't it? But milk will be same. So 42 liter milk will be as it is. But they are adding again 16 liters of water. So 6 liter plus 16 liter. So now milk will be 42 liter and water will be how much? 22 liter, isn't it? So at the end, milk and water will be in the ratio how much? Milk is to water will be how much? 2 21s are 2 11s are. Therefore, milk is to water will be 21 is to 11. Okay, at the end, again the milk and water will be in the ratio 21 is to 11. Next problem. A mixture contains milk and water in the ratio 6 is to 5. When 33 liters of mixture is replaced by same quantity of water, then ratio becomes 3 is to 4. Find initial quantity of mixture. So there is a mixture which contains milk and water in the ratio 6 is to 5. 33 liters of mixture is removed. Okay, it is removed. How much is removed? 33 liters is removed and it is replaced by same quantity of water. So whatever is the remaining mixture, okay, the remaining mixture also will have milk is to water in the same ratio, that is 6 is to 5. Then they are saying again same quantity of water is added. Okay, added. Again water is added of same quantity, that is 33 liter. Okay, so then the ratio, new ratio will become how much? Milk is to water 3 is to 4. But we know that milk should be same because they are adding only water, but milk is changing here. So if we have to make milk same, what we have to do here? You have to multiply by 2. Isn't it? So when you multiply by 2, the new ratio will be how much? Milk is to water, the new ratio will be 2 3s are 6, 2 4s are 8. So it will be 6 is to 8. Okay. New ratio became 6 is to 8. So milk is now milk is same. See here. Milk is same now. 6 and 6, but water is changing. It is from 5 parts it became 8 parts, isn't it? Milk is same, but water is changing. How much it is changing? It is changing by 3 parts. Difference is how much? 3 parts. That means it is increasing by 3 parts. So this increment in 3 parts is due to what? It is due to the addition of 33 liters of water. Due to addition of this water, this increment in ratio happened. So if 3 parts is 33 liter, then 1 part is how much? 1 part will be 11 liters. Okay. Then find initial quantity of mixture they are asking. So to find out initial quantity of mixture, first we will find out remaining quantity, as we did it in earlier problems. So remaining quantity is how much? We know remaining is milk is to water is 11 parts. Okay, because 6 part water and 5 part 6 part milk and 5 part water, which is equal to 11 parts. So if 1 part is 11 liter, 11 parts will be how much? 11 into 11, which is equal to 121 liter, isn't it? So remaining is how much? 121 liter. But we know that when 33 liter is removed, 121 is remained. So initially how much it will be? Initially it will be 121 plus 33, which is equal to 154 liters. Okay, so initially what was the mixture? Initial mixture was 154 liters. So it should be here 154. Okay, option C is the answer. Okay, so with this we have completed mixture and alligation problems. So all types of problems I have solved here, and the short methods how to solve also we have discussed. Okay, so please watch the video again and understand the problems. Okay, thank you.